Chapter 11 is purely an introduction to calculus, and the first couple sections are very straightforward. So we're going to combine both A and B today. So calculus really starts with the, the discussion about slope or gradients. Think about the word rate of change. Rate of change or your gradient is the rate at which one variable changes with respect to the other. And if you're looking at a distance versus time graph, this shows the gradient actually tells us the speed. So think of your common rates. Rates are speed because that's miles per hour, dollars per hour. A rate is just a comparison between units, and we're going to start real nice and easy here. All right, so that's what I was saying earlier. A rate is just a comparison between two quantities with different units. Anytime you use the word per, runs per innings, points per game. And if you think about when you find the slope, what does slope equal? The change in y over the change in x. So you're comparing the y unit per the x unit. That's why slope is always your rate of change. Okay, so this is just showing a graph that we can see that we started 0, 0. So then they took the table and just graphed it here. The gradient just gives the rate of change. That's probably the big idea. All right, so if we look at this graph here, if we want to find an average rate of change over a particular time. All right, so let me just stop this part of it. So I want you to think about if you were to travel to Cedar Rapids and you started in Waterloo, you have stoplights, you kind of speed up, slow down. To figure out your average speed that it took you to get to Cedar Rapids, you take your average speed, you would take your change in the distance, how far it is, divided by the change in time. Distance divided by time always gives you your average speed. All right, so think about, does that tell you exactly how fast you're going at every moment in time while you're driving? No. So your average is different than your instantaneous. So this whole beginning part is all about average. The average rate of change is just the slope formula. Okay, so seriously, the only thing you're going to be doing in this particular section is finding the slope of 2 points, the slope of the curve. So like, if we look at this example here, if I want to find the average rate of change over a time interval, say from 0 to 2, I would just find 0, 5, and 2, 20. Your rate of change is just the slope, 20 minus 5 over 2 minus 0, which gives us gives us 7.5. 7.5 degrees Celsius per minute. So the first unit's just understanding that the average rate of change is just the slope of 2 points. And that's your homework. Then B starts to get into the instantaneous rate of change. So like thinking back to that going to Cedar Rapids. When you're driving to Cedar Rapids, how fast are you actually going when you pass the Brandon exit? That's an exact speed at an exact moment. instantaneous speed or instantaneous rate of change is the tangent to a curve. All right, so I have this picture here. Let's remember your geometry. A chord touches 2 points of a curve. A chord is your average rate of change. The chord represents average rate of change that has slope of 2 points. Your tangent, remember, touches a curve at exactly 1 point. The tangent touches at exactly 1 point. This is instantaneous. Tangent represents instantaneous, and the average is the slope of 2 points. Now, if we want the instantaneous rate of change, you just want the slope of the tangent line. So where the slope of 2 points is the average rate of change, the slope of this line at 1 point is your instantaneous rate of change. For example, if we want to find the tangents drawn to find the instantaneous rate of change at A, we're going to find the slope of this line that touches the curve at A at exactly 1 point. We'll notice what is this line has a slope of up 1 over 1 all the way across. Because the slope of the line of A is 1, we say the instantaneous rate of change also equals 1. Now look at letter B. All right, we have to find exactly where it touches corners so I can find my slope exactly. So I'm looking at these 3 points and I go down 2 over 1 because my slope at line B is -2. My instantaneous rate of change is also -2. So notice when the graph is going up, it will have a positive instantaneous rate of change. When it's going down, it will have a negative instantaneous rate of change. And that's all that section B is about.